Good morning, ladies and gentlemen. Welcome to the Electrical and Mechanical Engineering Technical session of the Faculty of Engineering International Research Conference 2022, General Sir John Kothalavala Defence University. First of all, let me introduce the session chair for today's session, Professor Dushantha Jayakody. Professor, I would like to kindly invite you onto the head table here. Thank you very much, sir. Now I would like to invite all the authors who are presenting in today's session onto the head table as well. Thank you very much, everyone. Before starting today's session, let me give you a brief introduction about our session chair today, Professor Dushantha Jayakody. Professor Dushantha Jayakody completed his master's degree in Electronics and Communication Engineering from the Department of Electrical and Electronics Engineering, Eastern Mediterranean University of Turkey. He completed his PhD degree in Electronics and Communication Engineering from the University College of Dublin, Ireland. From 2014 to 2016, he served as a postdoctoral research fellow at University of Tartu, Estonia, and the University of Bergen, Norway. From 2016 to date, he is serving as a professor at the School of Computing Science and Robotics, National Research Tomsk Polytechnic University, Russia. Since 2021, he is serving with the Autonoma Tech Lab, Portugal, and Universidade Autónoma de Lisboa, Portugal. He also serves as the Director of Postgraduate and Research, Sri Lanka Technological Campus, SLTC, Padukka, Sri Lanka, and he is the founding head of Center for Telecommunication Research, SLTC, Sri Lanka. In addition to that, he held visiting and sabbatical positions at Centre for Telecommunication Research, University of Sydney, Australia in 2015, and Texas A&M University in 2018. He is also a senior member of IEEE and also a fellow member of IET. Professor Jayakody has also received several awards over the years for his contributions to the research community. In 2017, he received the Best Paper Award at the IEEE International Conference on Communication, Management and Information Technology. In 2017 and 2018, he received the Outstanding Faculty Award by National Research Tomsk Polytechnic University of Russia. In 2019, he received the Best Paper Award at the International Conference on Emerging Technologies of Information and Communications in Bhutan. In addition to that, he received the Education Leadership Award from the World Academic Congress and the Distinguished Researcher in Wireless Communications in Chennai, India in the same year. Professor Jayakody has published nearly 300 international peer-reviewed journals, conference papers, and books. He has supervised over 15 PhD students, many master students, and undergraduate students as well. Professor Jayakody's research interests include physical and net layer perspectives of 5G communication technologies such as NOMA for 5G, cooperative wireless communications, device-to-device communications, LDPC codes, unmanned aerial vehicles, and so on. In his career so far, he has organized and co-organized more than 30 workshops, special sessions, IEEE conferences, and he has also attracted nearly $6 million worth of research funding. He currently serves as an area editor of Elsevier Physical Communication Journal, MDPI Information Journal, MDPI sensors, and Wiley Internet of Technology letters. In addition to that, he serves on the advisory board of MDPI Multidisciplinary Journal, and also he has contributed as the reviewer for various IEEE transactions and other journals as well. So, Professor, over to you, sir.
Am I audible? Can you hear me? So good morning to all of you. Let me formally open the first technical session 1, parallel session 1. For this session, we have about 4 papers lined up, and I hope that it will be a very fruitful discussion with the authors. And in order to reap the benefit of any conference, so the audience should, get engaged and ask questions. So there is no right question or wrong question. So feel free to ask, and put forward your ideas for the growth of the future. So the university has put a lot of efforts in organizing this. So it will be only benefited if we engage in the discussion, right? So with that note, I would like to welcome the first speaker of the day. We have the first paper title, Home Automation Application Using Raspberry Pi 3 and Windows 10 IoT. The presenter is Engineer T. Kugaranan. So he received his first degree from the Southeastern University of Sri Lanka in the field of Electrical and Electronics Engineering with a second class honors upper division. He is currently a temporary assistant lecturer at the Department of Electrical and Telecommunication Engineering at Southeastern University of Sri Lanka. He is currently following his MSc in Electrical Power Engineering from University of Maldeniya. Over to you, Kugaranan.
Good morning to all. I think my name is Kugaranan. I am from Batticaloa. I studied my bachelor's degree in Southeastern University of Sri Lanka in the specialization of Electrical and Electronic Engineering. Currently, I am working as a temporary assistant lecturer from the same university, and also I am following a master's degree in Electrical Power Application at University of Maldeniya. This is my basic introduction. Now, I directly move to my presentation. My research topic is home automation application using Raspberry Pi 3 and Windows 10 IoT. Okay. I divide my presentation into these other small parts. The first one, I will focus about the introduction, and the second one, future of the system, and the third one, my research objectives and scope, and the fourth one also the hypothesis, and next one should be methodology and the altogether results and some difficulties, and finally I will conclude with my reference part. The first, the introduction part. Normally we know the CEB is the electricity provider in Sri Lanka. They are doing generation and transmission and distribution, also doing an electricity retailing. One of the major problem in CEB producing higher demand electricity with allocated fund. Nowadays we know there are some issues going on. The financial crisis of CEB is not only a problem for the CEB, but also the problem for development of our country. The lack of knowledge among consumers about their electricity tariff system is the major reason for the problem, because nowadays we don't know how to use the electricity efficiently, then how to reduce the electricity wastage and those things. In those things I will touch with my presentation. The end solution is a simple single device that can act as a smart home automation as well as assist and give suggestion to user to optimize the power consumption. Here I developed one system. That system tells how to use efficiently and how to reduce the wastage into human level. Okay. In my system has some features. These are the features I mentioned. The first one, the electrical appliances can be controlled by dedicated display panel. Using one display panel, I can control our electrical appliance. The second one also, electrical appliances can be controlled by remotely using smartphone. We can use smart devices or any mobile or tablet to control our devices. The third one, the power consumption of each appliance can be monitored. Maybe I will show everything into our detail. The fourth one, the status of the room temperature and light intensity and presence of human can be observed. Using this application, we can check our each and every time temperature, how much temperature in the room, what is the light intensity level, and how much the present humans in our rooms. And the next one, the home lighting system can be controlled automatically with room light intensity. Depending on the room light intensity, we can automatically control switch on and switch off the bulb system. Likewise, the next point is automatic switching between fan and air conditioner with respect to room temperature. Depending on the room temperature, we can automatically switch off and switch on the fan. The last point, the Sri Lankan electricity tariff system and the ideal power saving tips also we added. Normally, in most of the consumers, they don't know how much about the electricity tariff system. Now how much is increasing, how to doing those things. And those things also we can add it into our system. Next slide, they explain the research objective and the scope. In our research objective, to develop an application with graphical user interface and to control the appliance effectively and efficiently. To make the home appliance flexible, control and smart mobile device and able to control the home appliance from remote location. Okay. The next point, to make an automation system which can control the application automatically. Here I show one fixer. For example, using a mobile phone or tablet, I can control our devices. What are the devices working now in our home or everything. And here I mentioned one hypothesis for this research problems. The aim of this project to make a smart home environment, and addition to that, drives the awareness to the customers. Nowadays, most of the customers don't know about how to use and how to do that. That awareness also we are given to our system. Yeah. Now I will move to the directly in my system. In my system has the 3 layers. The first layer I use the one mobile device. Using that mobile device, we can control the final, the right side one figure showing. Using one Arduino module, I can connect. There are 3 sensors and 1 relay module. Using these 3 sensors, the first one should be the passive sensor, passive IR sensor. That using that passive IR sensor, I detect the human detection. The second sensor is the LDR sensor. Using this light dependent resistor, I can check the light level in our room. The third one, the LM35. LM35 is the temperature sensor. Using that LM35 sensor, I will measure the temperature of the room. The fourth one, there is one relay module also added. In using that relay module, we can connect several devices. For example, here I show maybe one bulb or some fans or some plug point. Everything we can connect it. Okay. Using this Arduino system, first thing, I will get the sensor signal from these 3 sensors and relay module. Then after that, I will send that sensor results into main device. Our main device is Raspberry Pi 3 model. Then after getting the Raspberry Pi 3 signals, then Raspberry Pi 3 signal sends some status to our mobile device. So here I can use any Android application or Windows application to control our temperatures and maybe light level and the human detection. Okay, these are the basic three. And here I will show only the sample of one room. I can connect in several rooms in our one home. Okay, for a one home I need a one setup. Okay, for a one setup, maybe one Raspberry Pi 3 and one Arduino, and there are some 3 sensors and one relay module I need. The all the theory things I already mentioned. These are the things I already show it in the previous slides. Yeah. Here I show that this is our systems. Okay, and system. This is the first graphical user interface of the system. The graphical interface of the system showing some time and the date of the things. The second one, see this. Our graphical interface system has mainly 4 tabs. Okay, the first tab showing what are the rooms connected to our main devices. For example, here I show there are 2 rooms, maybe one living room and one kitchen rooms are already connected with our system, and I will monitor those are the sensor details and relay module readings from these 2 rooms. And the next slide showing the inside one room, what are the devices now connected. Okay, for example, here I show there are only 2 devices. The first, the left side device is bulb, the second one should be fan. And altogether, in the living room there are small 4 display. That 4 display showing the first, the left side one is showing none. Here I think I take the photo before connecting Raspberry Pi. That's why there is no reading is showing from this display. The left side, the black one is showing none. None meaning there is no presence detection. We can check the presence detection using that passive IR sensor. The right side one showing the LDR level, light intensity level of the rooms. The third one is showing the temperature sensor reading. The fourth one showing how much power we are using for now. Maybe for example, if you connect 2 devices, how much power consumption about now. Likewise, we can check with throughout 1 month, we will calculate automatically how much our electricity bill. Depending on that bill, we can use, maybe next time we will reduce the wastage, or we can get some awareness about our electricity bill. And here also in my application, I added some electricity bill standard for some awareness of consumers. Consumers normally they don't know what about the electricity tariffs going. Maybe when you use 60 units, how much our electricity bill. When you use maybe 90 units, how much electricity bill. Those things they don't know. If you showing this electricity tariff system also, they can get some awareness. Likewise, the last tab, I show some general tips. Okay, in the general tips and some efficiency. Yeah, okay. And using this general tips, I can awareness of the consumers, and consumer can get some idea to reduce the wastages and use the electricity efficiently. And this is the last step. I show maybe these are the several devices I can connect to my application. There are examples of some devices. Finally, here added some results and conclusion. And the first one, for the power measurement, I need voltage measurement and current measurement. For the current measurement, I use some clamp sensor to measure the current sensitivity test. For example, here I show there are 3 devices, and I measure the multimeter reading and my system reading. And mostly, my system reading nearly lesser than 5% error. Then mostly it should be accurate to multimeter reading. The second one, for this module, I used some Wi-Fi module to transfer data from Arduino to Raspberry Pi. For that Wi-Fi, I used NRF24L01 module. That Wi-Fi module also, I can use the normal condition 40 meter And for the with cover condition, normally I need to use some cover condition. I can use the 36 meter. Likewise, if you use that inside the room, maybe it should be coming to lesser than 5.2 meter. And the temperature test also, I checked with my device and some other phone sensors and online weather in my device, showing the accurate value 31.19, and other two values are nearly same. The last one, and for this voltage and power measurement, I used some voltage transformers to measure the voltage and current sensors to measure the current. And there is a small, there is a 3 limitation for this my devices. In my device, anyone not to the technology, it's make for a lot of time to spend, understand. Maybe the nowadays normally most of the people are working with the technology things, but some other people are not good at the technology things. Then it's very difficult to using my devices. The second one, any failure of bugs in the software or hardware will have serious consequence. Likewise, I used here for the Arduino program, there are some delay function. That delay function also has some limitation. Yeah, finally, I added some references to refer this. Thank you for my presentation.
Okay, thank you very much for your nice presentation. Yeah, we have a couple of minutes for questions and answers.
So your system needs a separate rewiring of the entire electrical system in the house.
Yes.
So that will add to a serious increase of cost, and it denies the application of your system for the existing installations.
Yeah, maybe.
So how can you comment about this restriction?
I need to fix this system. It's already existing wiring systems, and additionally, nearly I checked in my total cost around 50,000. If you use one time 50,000, we can get it maybe nearly after 3 or 4 months from this amount one. Because of maybe we can check with the electricity bill and some awareness of those things, then consumer can reduce the cost, electricity cost, and they will get the benefit of this installation cost from after 3 or 4 months. Thank you.
Any more questions?
Okay, let me ask you a question. For example, now, how many sensors you use for one parameter?
Yeah, for one room.
Only one sensor.
Yeah, no. For one room, I use 3 sensors. One for temperature measurement.
Per parameter, how many sensors you use?
Per parameter, already I checked with the 4 sensors, but I select with this sensor is the
Temperature, how many sensors you use?
temperature sensor. One sensor. This is the most effective one.
Okay, let's assume in a hall, so you are using one sensor at a place. So can you assume that the average temperature prevails? If that is the same what you did it?
Yeah, I think nearly same, but not exactly one. Because of when you use the big room, that's maybe not good.
Should have mentioned it.
Yeah, I think we are developed.
When you say about the limitations.
Yeah, yes. We are developing the system nearly the small rooms like that, one home.
You said you can make it profitable after 3 or 4 months?
Yeah,
Did you do some calculation? I don't know whether you showed it.
No, I didn't show those.
No,
things.
because
Yeah.
if you talk about 3 or 4 months, it's very unlikely we'll be able to do that because you're controlling. How are you going to gain that? Now you have to answer that.
Yes.
So if you say you're going to recover the money in 3 or 4 months, what is the gain you are getting?
Yes, sir.
Convenience, yes.
Yeah. Maybe I think maybe after, maybe I will do those calculation and show it that one, like how much exactly return period and those things.
So there are also many home automation systems.
Yes.
Have you done any comparison to show your novelty?
Most of the home automation system has only controlling thing. There is no awareness and there is no electricity tariff systems. Now, those things are we added to this system to compare with those and these things. Our device is new.
All right.
So have you got an intelligent system which check how the consumption is, or you just show the...
No, we are developing the same system in my university. In one, there are some 3 rooms and 1 controlling main hall rooms, and we already fixed this.
No, to save power.
Yeah.
Is the system smart enough to decide when to switch on and when
Yeah.
to use?
In the display, always showing how much power is consumption now. Depending on that one, we can check it. What are the devices switch on? What are the devices now working? What are the devices consuming high current? And everything should be showing in the display. Depending on that one, the consumer can decide it, which one we will use. Those. Yeah, I think that smartly we can control it, but some idea you.
Yeah, smart means like it should, the
Yeah,
intelligence should be there.
Yeah.
So that your data should be read by a system, and some machine
No,
learning
but-
algorithm should
Yeah.
decide those.
If we develop
Yeah.
smart system like this, maybe sometime if we want to use washing machine and iron, maybe depending on the current level, that should be automatically switch off. That may be affected to consumers.
One more question. So, in addition to the temperature, why don't you consider the humidity, relative humidity of the room? Because the boundary points of the coordinates of the comfort zone depends on the temperature and relative humidity. Sometimes the relative humidity may relate with the number of persons inside the room.
Yeah. Yeah. Okay. Sure. Those things also we can consider in my future of the things. I will consider those.
Because for the AC machine, operation of the AC machine, that is very useful, and you can save the energy a lot.
Yes. Thank you.
Just a last question. So you have demonstrated the different errors between the manual calculation and what system returns. So I think that's a nice validation of what you are proposing. And in one of the parameter I saw it returns about 6% of error. What would you suggest to reduce the error parameter?
I need to do the calibration things, reducing the error and those things.
Is this error is average or it's just a one-time reading?
No, average one.
Average of how many times?
Maybe I did nearly 1 month readings and do the average one.
Right. I think that's all. Thank you so much.
Yeah. Thank you for the question and passion. Thank you.
Yeah. Let's move to the next presentation. So the next presentation is on the intelligent battery control mechanism for electric bicycles. It is by UVH Sameera. Sameera received his BSc degree in mechatronics engineering from the Mechanical Engineering Department of General Sir John Kothalaula Defence University, Sri Lanka in the year 2021. And he recently worked at Nikini Automation Systems as a control engineer trainee. And also he joined Kothalaula Defence University as a temporary demonstrator to pursue his career in academia. Over to you, Sameera.
Thank you, sir. So, good morning to the conference chair and the other distinguished guests. So, our research is based on the topic intelligent battery control system for electric bicycles. So, the outline of our presentation will be an introduction, aim, the methodology, design and the simulation and testing, results and discussion, conclusion, and then the recommendation and further developments. I would like to start my presentation with what is an electric bicycle. So simply we can say it is a regular bicycle with an additional drive system. This consists of a battery, a motor, a way to integrate the motor with the drivetrain, and a way to control the power. Electric bicycle provides many advantages compared to conventional bicycles. But there are a few limitations like per charge traveling distance, top speed, battery lifespan, and charging time. This research is focused to improve the per charge traveling distance of electric bicycle through an intelligent battery control system. The aim of our research is to introduce a rechargeable dual battery mechanism to manage and improve the per charge traveling distance of an electric bicycle. So I'll further explain what is dual battery mechanism. A dual battery mechanism means there will be two batteries, or a battery will be divided into two halves. And one battery will be used to drive the motor, and the other battery will be used to store the harvested energy from the energy harvesting mechanism. So this is the methodology of our research. So initially a research was conducted based on electric bicycles, rechargeable cell chemistry and the geometry, battery charging mechanisms, energy harvesting mechanisms, battery management systems, electric bicycle motors and controllers, driving modes, and battery charging and discharging cycles. Then on collected data, a conceptual design was developed and based on the design consideration results. The calculations, material selection, 3D modeling and simulations were carried out simultaneously while updating the final design. Finalized design was fabricated in a local workshop, and the prototype was subjected to road trials. So now the design and simulation and testing. To reduce the complexity in the design and simulations, the research was divided into few subsections. Those are battery pack and the control circuit, driving modes and the control circuit, engage and disengage mechanism of motor and the energy harvesting mechanisms. So I'll start with battery pack and its control circuit. Through the initial research, it was identified that not allowing the batteries to fully run through its charging and discharging cycles without interchanging is one reason to reduction in per charge traveling distance and the lifespan of batteries. This interchange in charging and discharging cycles also cause an increase in temperature and decrease in capacity of batteries. For this research, we selected 18650 lithium-ion batteries to build the two battery packs. The battery parameters are 48 volt and 16 ampere hours each. All the cells used in the two battery packs were subjected to internal resistance testing and the capacity testing separately. Only the cells above 4 volts and 2200 milliampere hours were used in fabrication of the battery packs. So this is a block diagram of our battery control circuit. Both 48 volt batteries again divided into 12 sub-packs, where each sub-pack was monitored by 12 volt 20 ampere BMS units. Both main battery packs were monitored through battery control circuit, and pack with the higher SOC, that means state of charge, is assigned to drive the bicycle, and the other pack will be used to store the harvested energy. So this will allow the batteries to run through its charging and discharging cycles fully. Then 12 volt sub battery packs will be connected in series when it needs to run the motor. That means when it needs 48 volt output. When it needs to store energy, the 4 battery packs will be connected in parallel. This switching mechanism is controlled by a control circuit and 16 module relay. Then the driving modes and the control circuit of our bicycle. we have introduced 4 driving modes in this bicycle where the rider can choose based on their preference. First one is the electric mode, which is similar to a scooter. When the throttle is engaged, motor will provide the power and the bicycle will propel. Then the pedal assist mode. Here the power only provides when rider is paddling and based on the rate of paddling. Paddling speed will be detected by encoder. Will attach to the pedal axle. Then a scale pulse is given to the motor controller to drive the motor. Continuous charging mode is a new unique mode where the energy harvesting mechanism is always engaged to the drivetrain to charge the batteries. Here we face some drawback. A rider felt some load when continuous charging mode is activated. Then the neutral mode, which is similar to a conventional bicycle, both motor and energy harvesting mechanism will not engage while pedaling. Okay. A new concept called slope detection system was added to the system, which is unique feature and will help to harvest the kinetic energy of a bicycle while traveling in slopes. So when the bicycle traveling in slopes, it will automatically detect the slope using a gyro sensor, and it will activate the energy harvesting mechanism. The block diagram shows the user inputs, sensor feedbacks, and actuator signals of the driving mode control circuit. Engaging and disengaging mechanism of motor and the energy harvesting mechanism. So, reason behind introduction of this system is to avoid the unwanted drag on motor and the rider while moving in particular modes. Here the electromagnetic clutches are used to engage the motor and the energy harvesting mechanism to the driving system. Again, that is also based on the driving mode and the riding conditions. Further, this table shows how motor and the energy harvesting mechanism engaged in each mode. As an example, in electric mode, the motor is fully engaged and releases only when it detects slopes and also when brakes are applied. Here the energy harvesting mechanism in electric mode will engage only in slopes and when brakes are applied. So in neutral mode, there will be no engagement of motor and energy harvesting mechanism, but when it detects a slope in neutral mode, it will automatically activate the energy harvesting mechanism. Then the results and discussion of our research. Developed dual battery mechanism was subjected to road trials under each driving mode with 3 different drivers randomly. The road trials were carried out with and without the introduced system in the same bicycle. So I'll explain what is without the system. So for an example, in electric mode, without the system means same motor, same energy harvesting mechanism with a battery with same parameters, not a dual battery mechanism. So we used a GPS speedometer mobile app to measure the traveling distance, the speed of the bicycle, and track the route of the route we did the testing. So in diagrams here we can see the routes, and this is the display of the bicycle, and this is our prototype. Then in electric mode, usually what happens is motor is fully engaged there, so it releases only when apply the slopes and brakes. So here the results, the per charge distance without the proposed system was 34.5 kilometers, but with the proposed system, per charge traveling distance was increased to 41.6 kilometers, which is 19%, almost 19% increasement. Then in pedal assist mode, the per charge traveling distance without the proposed system was 49.4 kilometers, but with the proposed system, per charge traveling distance was increased to around 55, so which is 11.34 increasement. And here in the continuous charging mode, the rider is always, this is also based on the preference of the rider. So he can select if he need to burn some more calories, he can use this mode. And also it will charge the batteries while riding. So, but unfortunately, the rider needs to cover 61 kilometers to fully charge the battery, at least with 20 kilometers per hour speed in the bicycle. That is a small drawback in the research. So as a conclusion, we developed an intelligent dual battery control mechanism integrated with 4 driving modes, and developed system has improved per charge traveling distance in electric mode by 19%, in pedal assist mode by 11%, and continuous charging mode it needed almost 61 kilometers to fully charge the battery. So recommendation and further developments, the bicycle is suitable, ideal for urban cities like Colombo, where there are more flat roads are there, and also could use to domestic activities and also in commercial activities like Uber Eats, Pick Me Foods, like applications. We could use of a chassis with lightweight material like carbon fiber would affect more compact design and increase the load on motor. So that will increase the traveling distance. So, and also could use a motor generator replacing both motor and the energy harvesting mechanism. So this is the references.
Yeah, thank you, Sameera. It's time for Q&A.
That means, sir?
I mean the rechargeable system, sometimes while moving it in the downward slope,
Yeah. Actually, sir, we
I need
didn't
to know the efficiency of the regenerative power system.
Yeah, actually, sir, we used an alternator. We didn't separately measure the efficiency in that in energy harvesting mechanism. What we did was we conducted the trials with and without the system, and we measured the increasement in distance, because our aim was based on to increase the per charge traveling distance of the bicycle.
Can I ask a question?
Yes, sir.
Yes. Now, the comparison, did you use with 2 batteries in both cases?
Yeah. Like with the same, in dual battery mechanism, we have 2 capacities. Like capacity increases by double.
In single.
Yeah. We use the same battery.
Right. Did you remove all the additional things in your bike when you tested?
What we did was, we had a relay mechanism. So we program it to connect.
No, I'm talking about weight.
Okay.
Now your system would have added weight to the electrical bicycle.
Yeah, exactly, sir.
So did you remove those parts?
No.
No, because without that, your gain is maybe 10 or 15%. What was the weight of
the bicycle?
The additional parts that you added?
The weight of the whole bicycle was 23 kilograms.
Yes.
With the battery pack and all. With chassis was weight around 3 to 4 kilograms. So
Because then you should compare. You have increased the weight by a certain percentage.
Yeah.
If you added additional batteries, what would you have got?
So
otherwise, your comparison is not really correct.
Okay. So what we thought was, like, if I remove one battery, so that will reduce the capacity of the battery. So we electrically make them parallel by making double the battery, using the same battery.
Can I ask one question?
Yes, sir.
So here, one of the important point that you mentioned in your system, that you use 2 battery packs, one for charging and one for discharging.
Yes, sir.
So you claim that is this the main point behind your improved distance per charge?
Sir, in one part, this is a part of our project. One of the main part was improve the lifespan of the batteries. So in this part of the research, we tend to increase the traveling distance of the through a battery.
But usually the conventional approach is to use a single battery pack.
Yeah.
So in your case, it will be two numbers of 16 ampere hours. So altogether it comes to 32 ampere hour. It's a reasonably large battery.
Yeah,
it's okay. So we can use the same battery for charging and discharging, but only you have to change the power electronics a little bit.
Yeah.
But so that option you can compare whether that option would bring a different result
Yes.
compared to your system, which needs more hardware and space and weight.
Yes.
And also, if you are continuing this project further, I would even suggest to consider using some amount of supercapacitors for pickup purposes, so that you can save the battery life by letting the capacitors to work on such modes.
Yes.
Thank you. And one more question here.
Yes, sir?
Why I saw in your control system you put a gyroscope?
Yes.
What is the purpose of putting that? What is the
So we introduced a slope detection mechanism. So when the bicycle travels in slopes, it automatically activates. There's a kinetic energy stored in the bicycle. To harvest that, through the gyroscope, it automatically actuates the energy harvesting mechanism.
One more question. While congratulating your product, let me get a quick fix. Now, I understand there are a number of products available in the market.
Yes,
so
sir.
compared to that, where you position your product in performance-wise?
So I think this is still in research. Only difference in our bicycle, other than the bicycles in the market, is so we have integrated the four driving modes with the dual battery mechanism. We have compared our bicycle with Roda bicycle, which was recently introduced, and actually in our bicycle the advantage is the mechanism improves the traveling distance.
In an urban environment, can you achieve 20 kilometers per hour?
Yes, sir. We have results through the mobile app. It gave the 22, like that was the maximum speed we achieved.
Okay.
We didn't take the calculate the average.
Yeah.
You evaluate for the best conditions.
Yes, sir.
So you should check the practical
average
conditions.
Yes. Thank you, sir.
Thank you. I think, Sameera, you did a very timely invention, especially as the country is at the default situation. So I just have a couple of questions. So in the title you use intelligent.
Yeah.
What is the intelligent in your invention?
So here, sir, it automatically actuates when consider when one battery drains out while driving the motor. So it automatically interchanges two batteries.
So it should be automatic.
Yeah.
Not the intelligent. Okay. I suggest that you remove this part, and otherwise it might be misleading, no, for the future inventions. Yes. So one more thing is, so what is the? Did you look at the efficiency of the energy harvesting batteries? Because there is, the efficiency, like when you are charging, the not entire percentage, 100% will be charging. There is a loss in the charging process, and the discharging also when you are retrieving the energy.
Yeah.
Have you looked into that?
Not, sir. Not in this research.
Okay. So maybe you can consider, to develop to the next level.
Yeah.
Right? Thank you, Sameera. Thank you.
Thank you.
Right, we are moving on to the third paper. So that is on comparison of printed circuit boards fabricated by using conventional method and the laser cutting method. The presenter is Karunarathne. Pramod graduated in 2021 with BSc Honours in Mechanical Engineering from Kotelawala Defence University, Sri Lanka. He is currently the Managing Director of Uniglobe Trading Private Limited. He is an independent researcher. His research interests include sports science, unsupervised natural network, and development of wearable devices for rocket-based sports. Over to you.
Good morning, everyone. This research is comparison of printed circuit boards fabricated by using conventional method and laser cutting method. Let me explain about the research. So first we made a CNC machine, so you can see that. After that we did some research on that. I will explain the conventional PCB manufacturing method. First, print the circuit diagram on a paper. Most probably it can be glossy paper. Then paste it on the copper board and iron the board. Then remove the board. You can see in third picture. Then dip the PCB into the etching solution, ferric chloride solution. Then remove the ink by rubbing it with steel wool, and you can see it in fifth image. And sixth image, finalized circuit board, you can see that. Disadvantages of conventional PCB manufacturing method. The first one is difficult to achieve perfect tracks by ironing, and thus resulting in improper electrical connection when electronic components are soldered onto the board. That is first one. And second one is process is time consuming, and there are many more disadvantages. So the proposed PCB manufacturing method, the first paste the sticker, we get a sticker and paste it onto the copper board, then cut the circuit path by using a CNC laser cutter. Most probably it is engraving laser cutter and with 2-watt laser. Then remove unwanted sticker parts. So you can see that in second image, and then dip the PCB into the etching solution, ferric chloride solution. Then after that, in the third image, you can see remove sticker parts. So you have to remove the sticker parts in third image. Then the advantages of proposed method and comparison with conventional method. You can see clearly the proposed method easy to achieve perfect tracks. The process is time saving, and when we are comparing with conventional method is some tracks are erased and difficult to make circuit boards with thinner tracks. So now we are going to do a comparison of conventional method and proposed method by using image processing. The first image is the template of the circuit, then A image, image D, the template with color inverted of the A, then the B, PCB made using homemade method or the conventional method, E is binary image of image B, and then the C is the proposed method. The binary image obtained from C is in F image. So you can see that. So now we are going to find the similarity score. So now that is why we get these binary images. The D image is the template, and we are comparing it to E. E is the binary image of the conventional method, and the F is the proposed method, binary image of content obtained from the C or the proposed method. Now you can see we obtained the similarity score of E, conventional method, is 0.63, and the similarity score of proposed method is 0.92. So then we find optimum power by varying the laser power and cut rate, because we need to find the optimum power for this laser cutter, because the laser can be vary from 1.5 watt to 2.5 watt. So first we are trying to find the optimum power. So we made 4 PCBs. First one is A, B, C, D, and there are different cutting rates and different powers. So if you see clearly, the B and C images has perfect or the good fine tracks other than the A and D. So we can see that optimum power can be something like 2 watt. So we got the 2 watt from this. After that, so we are finding the similarity scores of PCB tracks at different cut rates while keeping the power at a constant value. So we kept the power at a constant value because it is better to keep the power at constant value. If not, there can be some problem with the laser cutter, because there is a low watt laser cutter machine and low power low watt laser cutter machine. So then 2 watt was the optimum power. So then we got some cutting rate. You can see that only 4 values in the chart, but we got we manufactured around 20 PCBs. Then we plot this chart, similarity and the cutting rate. You can see the graph was like this. So after that, the power was kept constant value, then we vary the cutting rate. So after that we obtain this function. The function fx has local minimum and local maximum, and the range from x from 0 to 60. Above this equation can be used to obtain the highest similarity score. So if you want to see what is the highest similarity score, so you can see use this equation. These are the references.
Thank you so much. And time for question and answers.
Which students use to make PCBs. If you're having a laser cutter, then I don't think you should compare with the age-old method. Now, quite often you send it to China. So your advantages may be, without sending it to China, you may be able to get the same quality product locally.
Yeah.
So I think you should not compare with the homemade thing, because obviously the quality, for example, even if you take a printout, if you take a printout from a laser printer or an inkjet printer, there's a difference in quality. So I'm not talking about a project. So comparison, if you can also do with what is done abroad, and then find out the optimum configuration, which I think we have already done. That would be a good thing.
Any more questions?
What type of laser energy that you use, because you apply the laser energy to the metal plate, there might be reflections, and with the reflections sometimes it will damage the remaining part of the copper plate.
No, the 2 watt laser cannot damage copper boards or any metal.
No, any metal. And for different types of copper plates, sometimes the depth that it is penetrate might be changed. I mean the different type of copper plates. The harder one will make a less depth.
As I know, the 2 watt or low watt lasers cannot engrave or do anything on the metal plate.
Metal plate.
So as I remember, you need at least 40 watt or 100 watt. No, at the 100 watt laser also cannot do anything on copper or any metals.
Metal.
Any questions? Great. Just a small thing. So do you use any analysis for the energy efficiency of the design, like to compare with this traditional one?
We did the time comparison. Energy comparison, this is somewhat difficult to achieve.
I see. Yeah. And yeah, I think if there's no more questions, thank you. Yeah, sure.
Using this laser cutting method, we can achieve up to 20 mil. 20 mil is the laser boards or circuit board.
Engineering and the head of the Department of Aeronautical Engineering, and our instructors and all our parents and siblings. Thank you.
Thank you very much. That was a very nice research done by two authors, especially regarding the present day requirement. That was a very innovative thing. You have, if you can implement, especially that we have to check that one.
Yes.
So practically. Sir, now we would like to take this session for Q&A. If you have any questions or if you want to clarify anything regarding this research, you can ask. We have 2 minutes.
Thank you. Thank you so much. For the first time, I came to know that the thermographic image can be used to study the surface morphology of any paint surface. Maybe with this, now we can check whether there is indent or something unusual thing on the surface. But I wonder when because it is a IR based camera, if the temperature of the surface increased, so are there any method to normalize the other points?
So we've developed this prototype in using the assumption that this testing will be carried out inside a hangar. So by the time the aircraft lands and gets into a hangar, we assume that the temperature will be around 35 degrees Celsius, which is the temperature that we have obtained our image data set.
Okay, thank you so much.
Thank you.
You said the machine learning, you use one algorithm. Can I know the algorithm you used?
So we didn't use a machine learning algorithm here, but what we did was we checked whether we should use the machine learning algorithm or whether we should use another algorithm to do it. So when we checked that, we realized that this particular application will only have two classifications: no defect and defect. So we realized that in the machine learning algorithm, using a machine learning algorithm will be more complex, and with our project time constraints, it will be better for us to invest our time in other things rather than here. So we went with the image segmentation.
Okay, since you are going to develop this further, let me propose that machine learning should not be used for this type of applications. I think it is the deep learning you have to use. And as you have well cited in your second reference, they have also used the deep learning. I think deep learning is the best method for this type of application. So I'm just giving a proposal for further improvement.
Thank you very much, sir. We'll look into that.
Okay. As an aeronautical engineer, first I would like to congratulate you all at what you have done at undergraduate level. Congratulations to you. Again, as an aircraft maintenance engineer who have been in the industry, there are certain concerns that I have. I would like to add them, which would add more value to your presentation. So that first thing is, when you take an aircraft, there are different contours, because like it's not a flat surface. So that I think you'll have to take into consideration. And when you're looking at the lateral and the movement of the scanning process, once again, it's not equivalent. So that also you will have to take into consideration. So in future research, that would be highly beneficial. And also a practical aspect that I would like to add, when you're looking at the surface of the aircraft, the number of coatings and paints that we have is not identical. So that again is because, like, unlike in the commercial aircraft, especially in the military context, there are several coatings in there. So if you can add all these value additions, I think then this would be a very good idea. And I really would like to congratulate and try to test it on the aircraft. That would give you more insights to develop that. Thank you.
Thank you very much, sir.
That is last question.
Thank you for your informative presentation. My question is going towards the thermographic imaging that can be used in detecting surface cracks on helicopter blades. So, like you are using this to identify the surface defects in paint, can you improve it to like identify surface defects in helicopter blades? Because especially we are still using very inferior methods like tapping tests. So this can be very useful in that field.
Thank you, sir. So when we visited the Iceman Technical Center during the verification stages of our research, we tried to use their very concise equipment to check whether we can detect the surface cracks. And unfortunately, because the IR waves are being used here, the small cracks, that is the minute cracks on a surface, is not able to be detected just through thermographic inspection. So what I propose is we may be able to couple the thermographic inspection with say ultrasonic testing, so that it will go hand in hand and you'll be able to get the desired output that you want.
Thank you.
Yeah, Niroshan, if I add one thing to more, that is basically helicopters, rotor blades. That is especially this thermographic inspection, they are planned to design for the honeycomb structures. So especially water intrusion, to check that one. So that is the good idea for that one. Okay, sir, thank you very much then. That was a very nice presenter and that there are good Q&A session. You can see.
Thank you very much.
Thank you.
So our second topic today is going to be, that is also another very interesting aerodynamics topic, estimation of lift hysteresis of an airfoil in a low speed flow. So there are two, author is Mr. W.R.D. Jayakody. He is an undergraduate at the Department of Aeronautical Engineering at the Faculty of Engineering of Sir John Kotelawala Defence University. So regarding this topic, I think that is also very interesting one, and especially regarding the today's context, the unmanned aerial vehicle. The study of the properties of moving air and interaction between the air and solid bodies moving through its defined as the aerodynamics. It is one of the principal subjects that undergraduates of aeronautical engineering are supposed to undergo. Lift hysteresis of an airfoil is a phenomenon leads to difference, separation, and reattachment angle of aerofoil at an angle of attack near and above stall. This occurs when there is a difference in the lift distribution of an airfoil than expected for a given angle of attack when recovering from a stall. This leads to asymmetric flow parameters around body even when boundaries remain symmetric. These advanced aerodynamics phenomena, such as lift hysteresis of an airfoil, are necessarily required to be understood by the aeronautical engineers in order to design airframe structures or to estimate performance parameters of existing airframes. The interest on low-speed flows has been increased lately due to the increased application of unmanned aerial vehicles. The very phenomenon we discussed today, the hysteresis, is difficult to predict due to its inherent physics and extreme sensitivity to the environmental condition. In terms of acoustics, structural, pre-stream turbulence distributions. The research we present today will be based on the research undertaken by Mr. Jayakody and supervised by J.I. Abhayaguruvardhana to enhance to a spectrum of knowledge in this area to study. With that, I would welcome Mr. Author to present your presentation.
Thank you for the introduction, sir. Good morning, distinguished chairperson, senior officers, academic staff, ladies and gentlemen. Our research topic is estimation of lift hysteresis of an airfoil in low speed flow. So the outline of our presentation is as shown on the screen. So first, let me give you a brief introduction about what aerodynamic hysteresis is. So sometimes, even though the boundaries might remain symmetric, still when there is large regions of flow separation, this would result in instantaneous and mean flows to be different. So this could lead to hysteresis. Now hysteresis is the forces and the moments which are acting on a body could actually depend on the time history of the attitude. Now as shown in these figures, at a particular angle of attack 14 degrees, the oil flow visualization shows that initially the right wing has a flow separation, and then the left wing has a flow separation. So this has fluctuated, the forces has fluctuated. So moving on, our area of study is static stall hysteresis. So this static stall hysteresis means it refers to the dependency of the current state of the flow on the flow's history of attachment. So to simply put into words, it means for a particular angle of attack, for a particular airfoil, there exists more than one coefficient of lift, drag or moment. As you can see in the figure, the coefficient of
TDMA as the digital function. TDMA is a less power consuming scheme when compared to FDMA. In contrast, TDMA is an environment of small multipart delay can achieve high transmission speed. For the basic encryption, the DMR is built with software-based encryption. Software-based encryption is vital in ensuring unauthorized eavesdropping. The main features of the Creeper as flashed on the screen. It has 1000 programmable channels and 250 programmable zones. Technical specification of the Creeper given as in the screen. For the version 1.2 and 1.3, that is operate both the frequency, that is VHF and UHF, and it gives less weight, that is 258 grams. Further functional and operational details given in the own created user manual with the product for reference. The main part of the Creeper as flashed on the screen. The performance of DMR is first predicted on the basis of the specification given in detail during research phase and same tested by CDRD with available resources. This rain testing has carried out on different terrain in various weather conditions. Table summarizes the maximum distance achieved in different terrain. During field test, 200 number of handheld set conducted by Sri Lanka Navy. It has tested each and every parameters of Creeper DMR, and those test results were used for performance analysis. As per the figure, the voltage sensitivity of the Creeper is shown in the graph. As per naval standard, any given handheld communication set receiver sensitivity read as 0.25 microvolt. In the plot, it is indicating that 7 numbers radio have exceeded aforesaid values. The 3.5 radio's voltage sensitivity given some high values. This can be neglected when we communication proceed doing in digital mode. The output of the Creeper, output power of the Creeper is plotted in the as graph. As per specification, radio power output is 5 watt. However, results show that the output is varying approximately from 3.8 to 4.8 watt. This result shows that slightly some deviation in the expected result from the finished product. The scheme shows that the frequency deviation and the frequency error of the Creeper radio. According to the plotted graph, results show that 9 numbers radio having plus minus 1 kilohertz deviation in the frequency, and only 2 numbers radios given some frequency error that is more than 200 hertz. Only 2 numbers radio have given some frequency error that indicate 5.5% radio only have some frequency error, and all other radios are working satisfactorily. When considered the total average of working satisfactory percentage, it is creep 91%. Batches. Can I change it? Considering commercially available different type of handheld set, communication set with the creeper handheld set, comparison chart as given in the screen. It is clearly depicted that when the commercially available set, creeper given some good performance. With the advance of digital mobile radios, using popularity was gained by DMR, especially in the context of military communication. However, such commercialized DMR imposes a significant drawback in terms of capital cost, which also accounted for considerable amount costing of military and security services. According to field deployed test and field operation, Creeper successfully achieved the expected outcome. By obtaining these radios by tri-services, it could save millions of rupees flowing to other countries and saving foreign reserves in the country. In future work, considering all minor deficiencies, it is planning to design updated Creeper DMR version 1.4, incorporating the Sri Lankan Army 1 to 50,000 map features as expected. Also incorporating the Creeper in disaster management operation and develop further. In present scenario, many number of handheld set used in tri-services and they are working satisfactorily with good performance. Those are the communication set that we have already handed over to Sri Lanka Army, Navy, Air Force and VIP duties, that is especially for the Parliament and Defence Secretary, Defence Ministry. And very recently, due to the good performance of same, some number of radios are being used for peacekeeping force in Mali to enhance their communication capability. These are the references we use for our research paper. Thank you very much.
Thank you. Yeah. Time for questions.
How does the cost of your device compare with the... Now, in the last two columns, I saw the qualities were very similar. How would your cost compare with the corresponding one?
That is actually, when compared to ours, that is around 3 times than our commercially available.
Okay. Now, you said 5.5% of your sets have frequency problems. Now, isn't that a large number?
No, sir, that is small number. That is out of 200.
No.
Yes.
Percentage.
Yeah.
In engineering, I would expect anything more than 1% to be high. The person buying a product would not want to have... what is the frequency problems with the commercial other product that you are comparing with?
So actually, there was a frequency, some deviation, some error given, some error coming 1 point plus minus 1 kilohertz. That has to be in the, as per the specifications given. And also, sir, it's given some kind of
Is it due to the synchronization errors?
Yes.
Any more questions? No. So what kind of channel codes do you use here?
Sir, that is VHF and UHF, both the channels.
Yeah, so the do you use any channel decoding to improve the like the error rate performance at the decoder? So in your decoding circuitry, do you use any channel decoding, like LDPC codes or something like this? No.
No, sir.
No.
Have you checked what's the reason for the failures of the sets already?
So that is actually because of some problem with our designing. So that's designing parts. There was also some problem with the using some components. That was the problem, sir. So actually we have identified that one. So for the next version we are going to change that one.
And they presented, the results. If you look at the sensitivity and also the frequency error of the radios, maybe you can present more average results,
Yes.
Because currently they are zigzag. It's very difficult to get estimated error.
Yes.
What is the reality?
Yes.
So probably you can present much more, concrete
Yes.
ones. Yeah. And I believe if you use like a multi-user MIME or something, you can go up to 2.4 gigahertz, right?
Yes.
Yeah. To access the, above the VHF.
Yes, sir.
Any questions? Yeah, there is one question from very end.
So good morning, sir. Jaslin. My question is there any probability during operation for signal jamming, sir?
Signal?
Jamming, sir.
Jamming of the signals.
Yes.
Yeah, definitely. There is problem because whatever the frequency jam, we can't actually avoid that one. So it will definitely it will get jammed.
Thanks.
Same.
Yes, same.
Still,
Yes.
Yeah.
It was very difficult to read what was written. So when you are preparing a presentation, don't use this blue and black combination. The letters should be readable. Okay.
Yes, thank you, sir.
Yeah, can I do it? Yeah, I think what student ask is whether this is subject to jamming, like whether you use any hopping sort of thing, frequency hopping.
No,
for barrage jamming, I understand it is it will be jammed. But for spot jamming, have you got any countermeasures in this set?
Then we have to change the channel and frequency channel and avoid from that jamming, sir. Yes.
For students, right, this radio is not a specific radio which used for high-level encryption. So ECM with the VCM mechanism, we have not incorporated that also. The basic requirement is to establish communication in the common requirement. So for special operation, we have separate equipment and separate needs. So we apply according to our requirements. Even so, your question, massive MIMO we are not using because the range is become very low when we go to massive MIMO and high frequency. So to reach the maximum, we always use VHF, not the gigahertz rate. For other application, we go for the gigahertz rate, and we may use massive MIMO on that application. So especially in satellite communication.
Yeah. Maybe if you also look at this using of OFDM, like with the guard band interval to be a bit higher, I don't know whether that can be, save the frequency jamming. Yeah.
Or at least in future designs, have planned to adopt some hopping mechanisms or something?
Yes, sir. We can do that also. Even we are, because it has GPS facility now, we are going to incorporate that 1 to 50,000 map also, that is armament.
Thank you.
Yeah. Maybe also you can think of new 5G, application. I mean, there are many technologies projects, Mesiumaimo, Noma, and some of them to import to your design. Yeah.
We are doing that project, a research project.
Yeah, it's very nice. So actually, that concludes the today's technical session. Thank you very much.
Thank you.
Thank you very much, Professor, and all the authors for your valuable contributions to today's research community.
Right. So let me summarize the session today. So it was truly very interesting, 4 presentations, and they were largely Sri Lankan inventions. So we definitely need to encourage them. So all the questions that were raised by the audience to encourage your invention and bring them to the next level. So don't discourage of any. So this is how the research and development should move on. So the first presentation was on the smart home automation system that is designed with the aim of supporting Sri Lankan electric tariff and also practices. It has also impact on the smart living of the public. So as we are very used to the manual way of living, now we need to think on the smart cities. So the smart the meters and then smart home application should be the discussion in our day-to-day life. So I think that first paper brought that right intention and also the pointer across to the audience. So we know that IoT transformed our living. So it is time for us to, as being Sri Lankan, also think about how best we will use this technology and in the day-to-day life, how we can use one of the inventions presented by the author and also many other activities. And the second talk was on the intelligence, I would say automatic battery control mechanism for electric bicycles, if you don't mind. So that was again a very timely invention of the electric bike. Especially we are at the very default situation in the country, so there are quite many inventions are going on. So this specific invention has 4 riding modes and also a dual battery charging activities that help to prolong the life of the electric bike. The third presentation was on the comparison of PCB fabricated by using conventional methods and the laser method. So in the proposed laser cutting method, it was demonstrated that it is it's easy to achieve the perfect tracks, and also it is time efficient. The final presentation was another invention by the Sri Lankan Navy. So that was on the, they call it Creeper. That is the first handheld mobile device made in Sri Lanka. And it has a, a wonderful achievement for our level. And so with that note, I would also like to congratulate all the authors and would like to see the next level of their invention. And thank you very much.
Thank you very much, Professor, and all the authors for your valuable contributions to the research community. Now, we have come to the end of today's session. I would like to invite Professor Jayakody, accompanied by the head of the Department of Electrical, Electronic and Telecommunication Engineering Department, Captain K.K. Dadallage, to award the certificates to the authors who presented today. Engineer T. Kugaranan. Mr. U. V. H. Sameera. Mr. D. A. L. P. Karunarathne. Captain RMGC Navaratne. Thank you very much, everyone. Professor Jayakody, I would like to kindly request you to remain on stage for a moment. So now I would like to invite Dean, Faculty of Engineering, Engineer S.U. Dampage, accompanied by the Head of the Department of Mechanical Engineering, Captain D.S. Bogahawatha, to present the certificate and the token of appreciation to Professor Jayakody. Thank you very much, everyone. This concludes the end of today's session. Now we would like to kindly invite all of you to enjoy the refreshments which are arranged outside. Thank you very much. Have a nice day.
Recording stopped.
Good morning, ladies and gentlemen. It is my privilege to welcome you all to the second technical session on the day 2 of the 15th International Research Conference of General Sir John Kotelawala Defence University. You are here with us in the engineering session conducted on the theme of economic revival, national security, and sustainability through advancement of science, technology, and innovation. This session will be chaired by Air Vice Marshal LMSK Leela Ratna, retired, while the reporter will be Lady Officer Cadet AMBI Adhikari. Now, I would like to invite Air Vice Marshal LMSK Leela Ratna, retired, to the head table. I would also like to invite all the authors who are presenting in this session and the reporter to the head table. Thank you. Ladies and gentlemen, I have the honor of giving a brief introduction of the chairperson of this session, Air Vice Marshal LMSK Leela Ratna. Air Vice Marshal Kitsri Leela Ratna is an elite alumnus of the General Sir John Kotelawala Defence University. He joined the Sri Lanka Air Force in the year 1988 and graduated with a bachelor's degree in engineering. He also completed his master's in Defense and Strategic Studies from the KDU and completed his senior air staff course in Bangladesh. He also holds postgraduate qualifications in aircraft armament, technology from the US, aeronautical engineering from India, human resource management, and quality management from Sri Lanka. During his illustrious career in the Sri Lanka Air Force in the capacity of an engineer, he has worked extensively on fighter jets and served in several prestigious appointments, including Officer Commanding Maintenance of No. 14 Squadron, Commanding Officer Aircraft Engineering Support Wing, Staff Officer to the Director of General Engineering, Command Armament Officer, Command Quality Assurance Officer at Air Force Headquarters, and Staff Officer Technical to the Commander of the Air Force at the Sri Lanka Air Force Headquarters. Ultimately, he served as the Air Secretary at Air Force Headquarters and the Director Provost at Air Force Headquarters prior to his retirement. He possessed a wealth of experience in the military engineering field and has received specialized overseas training in aircraft armament, guided weapons, and ejection seats. He has served his alma mater as a visiting lecturer since 1999. He also conducts visiting lectures on aircraft armament and weapons technology to higher education institutions in the military. Now, I would like to thank you, sir. Also, welcome, VC, sir. An elite sportsman, Air Vice Marshal LMS Kugaranan, retired, is also the Secretary General in the Cycling Federation of Sri Lanka. Now, I cordially call upon Air Vice Marshal LMS Kugaranan, retired, to chair the session. Over to you, sir.
Thank you very much for the lovely introduction. So may I start, sir? Thank you very much, sir. Good morning, VC, sir, senior professors, Dean, Faculty of Engineering, all staff members, ladies and gentlemen. Once again, good morning to you all. First of all, I would like to thank Vice Chancellor of Sir John Kottala Defence University inviting me as to chair the session of technical session for the third time. So this is very rare opportunity as an engineering officer get from the Sri Lanka Air Force. So I am so lucky to have sir for the third time. So we know that I don't want to explain the vast areas covered by this university. So one of all students, the main aim of this exercise is to present their papers very effectively, to utilize, you minimize or whatever the resources available through the KDU, and to present to nation their capabilities and whatever the new innovatives. Today there are 4 researchers. They are going to conduct these research papers. First topic is thermographic inspection system for surface coating defects in aircraft fuselage. So all 4 subjects regarding these 4 topics related to the aircraft maintenance. So if I talk about the 2 authors about them, W.P.M.Y. Tilakaratne. Miss W.P.M. Tilakaratne completed the undergraduate academic program in the field of mechatronic engineering from General Sir John Kottala Defence University and is waiting for the graduation. Currently working as a temporary instructor at KDU. Her research interests include mechanical designing, control system and robotics. Regarding Mr. Ziad, the author, completed the undergraduate academic program in the field of mechatronics, engineering from KDU, and waiting for graduation again. Currently working as an executive automation engineering at Mars Holding. Sri Lanka, his research interests include machine design in automobile and robotics. So before the subject, I would like to give small introduction about the thermographic inspection systems. Regarding this is very special topic related to Sri Lankan context. Now we are doing the very old type of inspection system in the fuselage, identifying defects. Surface coating on an aircraft protect the skin of the aircraft from external damage due to corrosion, and it also reduce the friction between air and the surface, making them vital for aircraft operations. These coatings are prone to damage through various debris that also includes bird strikes. Damage to the surface coating will result in corrosion, damage the skin surface, and prolonged exposure to the elements. If unnoticed, and create catastrophic failure of the skin, which may result even in a crash of aircraft. To arrest this possibility, the manufacturers have detailed inspection procedure to inspect surface damages of aircraft skin. The first step would be identify damages to surface coating by way of visual inspection, and subsequent procedure of incorporating NDT methods such as ultrasonic, MPI, and X-ray to determine extent of surface damage. These procedures are time-consuming and makes aircraft grounding time for maintenance longer. In addition to experience of an inspector is a key component in identify probable damages as same as not easy to spot visually. The first research presented today by his team introduced an innovative technology to make this inspection much easier and cost-effective. They have researched the possibility of using thermal imaging technology and by analyzing the same through means of purpose-made software package to highlight the possible areas of damage to the surface coating. The team has concluded that by following this method and application of the technology presented efficiency, surface inspection could be increased up to by 9.25%. That is a huge margin. Further, same will also minimize the inherent disadvantages. So further ado, I would like to invite two authors to present their papers. Or to you.
Good morning, ladies and gentlemen. I'm Adil Ziad. It's an honor to be presenting you with our research study along with my colleague Monisha Tilakaratne. Our research study was conducted on the use of a thermographic inspection system for detecting surface coating defects on an aircraft. Firstly, our presentation today will proceed according to the following content. To start off, I will be giving you a brief introduction to the purpose of our research and how we were inspired to conduct it. When we consider an aircraft, protection towards its operating environment is very important. An aircraft's outer shell is protected from corrosion and deterioration using a surface coating. The effects of a damaged coating on the safety of the outer shell could lead to fatigue crack formation in extreme cases. The main causes of surface coating damage are impacts by particles, debris, and bird strikes. This highlights the role of preventive maintenance of the surface coating on an aircraft. So this brings us to the motivation to conduct our research study. The following are the key points for our motivation: realizing the importance of frequent successful testing and maintenance of an aircraft's corrosion-resistant coating, identifying the inefficiencies in manual visual inspection and the presence of alternate methods, recent popularity in thermographic inspection systems in the aeronautical industry, identifying the opportunity to advance and improve on non-destructive testing techniques using automation. Finally, the drawback identification of the existing thermographic inspection systems. To analyze the feasibility and the scope of our research study, we visited the Iceman Technical Center and attended a seminar on non-destructive testing done by the Sri Lankan Navy. This led us to confirm that damages to a surface coating are visible on a thermographic image. To investigate what aircraft to base our system on, we visited the Air Support Wing of the Sri Lankan Air Force, where the PT-06 aircraft was selected. This slide shows the analysis on existing thermographic inspection systems where aircraft outer shells are inspected by a person with a thermographic camera. The person needs to be knowledgeable enough to identify abnormalities, be consistent and on focus for extended periods of time. Moving on to finalizing our scope of the study, the aim of our research study was constrained to successfully designing an automated system that can test for surface coating defects on a scaled-down aircraft fuselage using non-contact, non-destructive infrared thermography and proving its effectiveness against the norm. Our objectives were as follows.
Moving on to the methodology, according to the finalized objectives, we prepared a methodology to successfully complete our research. To complete first objective, which was to design a scaled-down system, there were 5 distinct steps. Develop conceptual design, selection of materials, design calculation and model the design. Next step was to develop processing algorithm and motor controlling. And the final steps were to fabricate and test. Then we move on to the design considerations. As the first step of methodology, we developed a conceptual design, and best suitable design was selected based upon the design table with concise rating table. And here you can see the final design of the system was basically with 4 subsystems: rover, lifting mechanism, thermal imaging system and control system. Lifting mechanism was with 2 linear drives, and the thermal imaging system was with tilting mechanism and a camera assembly. This is the final 3D design of the system, which was modeled using SolidWorks software. For this system design, all the proportions were based on PT6 aircraft, and the total area coverage for one static placement of the system. This is the camera lifting mechanism, and here you have the camera tilting mechanism and the camera setup, and the trolley, and the control panel and the control box. Lifting mechanism, which is the main subsystem. It's a double-axis gantry consists with 2 linear drives which are driven by stepper motors, and the basic purpose of this mechanism was to carry the camera for scanning. Next, the second subsystem, thermal imaging system. There were mainly 2 parts in the thermal imaging system: tilting mechanism to make sure that the camera is perpendicular to the surface, and the camera assembly with FLIR Lepton 3 thermal camera. The control system had 2 subsystems which were controlled by 2 different controllers. Controller 1, Raspberry Pi, to control the image capturing and processing. Controller 2, Arduino Mega, for controlling lifting and tilting mechanism. For the controlling part, we need to identify the movement of lifting and tilting mechanism. Here you can see the path of the scanning system. And this is the control circuit of lifting mechanism.
Moving on to the thermal image processing system, we installed the operating system on our Raspberry Pi controller and installed all software dependencies for the thermal camera software that we used. Then we formulated the thermal image dataset creation and its analysis according to the following steps. We obtained 70 thermal images, including a spectrum of very different conditions, and then we manipulated them to make 560 images. Filters were then applied to enhance the images. In the end, we realized that machine learning was not the best technique in our case, and instead it was better to use image segmentation. This slide shows the initial thermal data set we obtained. This slide shows the total data set that we used for testing. The total data set was created by manipulating the original 70 images. This slide shows the results for the main filters we applied to enhance the images. We applied 2 image segmentation techniques to compare them. The triangle thresholding technique and Otsu's thresholding technique were analyzed, and the results were used to conclude the best thresholding technique, which was triangle method coupled with subtraction arithmetic filtering. This slide shows the control algorithm we used for the detection of surface defects. Firstly, the operator presses the start button, which is read by the Arduino as an input signal. Then the Arduino controls the camera positioning system to position it at the correct place. Then after it is placed correctly, the Raspberry Pi detects that and then proceeds with the image capturing and then the image processing, and then indicates to the operator whether a defect is present or not. Next, we move on to the fabrication part, which we proceeded with 3 phases. The first phase, the fabrication of the parts. The second phase, the fabrication of the sub-assemblies. And the third phase, the finalizing of all the parts and sub-assemblies together. This video shows the operation of our equipment. Unfortunately, we were unable to test the equipment on an actual aircraft due to COVID restrictions during our research. So this demonstration will just give a brief idea on it. For the purpose of this demonstration, we have simplified.
During the completion of system, each subpart, double axis gantry, tilting mechanism, image processing system was tested segment-wise prior to finalizing the design. Specifically considering the image processing system, different conditions that the thermal camera would be possibly encounter, such as low light conditions, high exposure, and shadow on surface conditions were explored. And a stock camera image with defect was analyzed using the same condition to justify the use of thermal camera instead of a normal camera. The 2 types of threshold segmentation methods were compared to confirm the system applicability. It was observed that the triangle method was better than the Otsu's method due to its effectively defining the foreground to the defect area, since it brought less amount of noise. And this figure shows the comparison of 2 thresholding methods and the noise appearance. After fully analyzing the source dataset, we were able to identify the pixel count range for defect image is between 11 to 108 non-zero pixels. Finalized system was able to cover the total area of 16,200 square centimeters per one static placement of the system. Compared to the manual inspection, total time taken for inspection procedure for one static placement, this system was obtained 18 minutes and 55 seconds, whereas the manual inspection took 20 minutes. Thereby, from this system, we were able to increase the overall efficiency by 9.25. In conclusion, this prototype was developed to introduce a novel concept to the surface coating defect detection in aircraft and to overcome the drawbacks of existing manual inspection methods. First 2 objectives, which was to design a scaled-down system for obtaining thermal image and process the image, were successfully completed through camera lifting mechanism and image processing system. Defect indication panel was there to complete the second objective, which was to develop a method that can indicate the operator. Finally, with the automated surface defect indication mechanism, we were able to reduce worker involvement and the total time required for manual inspection. This research continued on improving image processing system with machine learning algorithm, and further research need to be done to improve the system design with automated navigation system and IoT-based indication system. The references that we have used throughout our research are given here. And finally, we want to give our sincere gratitude to our university and Department of Mechanical Engineering and the head of the Department of Aeronautical Engineering and our instructors and all our parents and siblings. Thank you.
Thank you very much. That was a very nice research done by two authors, especially regarding the present day requirement. That was a very innovative thing. If you can implement, especially that we have to check that one.
Yes.
So practically. Sir, now we would like to take this session for Q&A. If you have any questions or if you want to clarify anything regarding this research, you can ask. We have 2 minutes.
Thank you so much. For the first time, I came to know that the thermographic image can be used to study the surface morphology of any paint surface. Maybe with this, now we can check whether there is indent or something unusual thing on the surface. But I wonder when because it is a IR based camera, if the temperature of the surface increased, so are there any method to normalize the other points?
So we've developed this prototype in using the assumption that this testing will be carried out inside a hangar. So by the time the aircraft lands and gets into a hangar, we assume that the temperature will be around 35 degrees Celsius, which is the temperature that we have obtained our image data set.
Okay, thank you so much.
Thank you.
You said the machine learning, you use one algorithm. Can I know the algorithm you used?
So we didn't use a machine learning algorithm here, but what we did was we checked whether we should use the machine learning algorithm or whether we should use another algorithm to do it. So when we checked that, we realized that this particular application will only have two classifications, no defect and defect. So we realized that in the machine learning algorithm, using a machine learning algorithm will be more complex, and with our project time constraints, it will be better for us to invest our time in other things rather than here. So we went with the image segmentation.
Okay, since you are going to develop this further, let me propose that machine learning should not be used for this type of applications. I think it is the deep learning you have to use. And as you have well cited in your second reference, they have also used the deep learning. I think deep learning is the best method for this type of application. So I'm just giving a proposal for further improvement.
Thank you very much, sir. We'll look into that.
Okay. As an aeronautical engineer, first I would like to congratulate you all at what you have done at undergraduate level. Congratulations to you. Again, as an aircraft maintenance engineer who have been in the industry, there are certain concerns that I have. I would like to add them, which would add more value to your presentation. So that first thing is, when you take an aircraft, there are different contours because like it's not a flat surface. So that I think you'll have to take into consideration. And when you're looking at the lateral and the movement of the scanning process, once again, it's not equivalent. So that also you will have to take into consideration. So in future research, that would be highly beneficial. And also a practical aspect that I would like to add, when you're looking at the surface of the aircraft, the number of coatings and paints that we have is not identical. So that again is because, like, unlike in the commercial aircraft, especially in the military context, there are several coatings in there. So if you can add all these value additions, I think then this would be a very good idea. And I really would like to congratulate and try to test it on the aircraft. That would give you more insights to develop that. Thank you.
Thank you very much, sir.
That is last question.
Thank you for your informative presentation. My question is going towards the thermographic imaging that can be used in detecting surface cracks on helicopter blades. So, like you are using this to identify the surface defects in paint, can you improve it to identify surface defects in helicopter blades, because especially we are still using very inferior methods like tapping tests. So this can be very useful in that field.
Thank you, sir. So when we visited the Iceman Technical Center during the verification stages of our research, we tried to use their very concise equipment to check whether we can detect the surface cracks. And unfortunately, because the IR waves are being used here, the small cracks, that is the minute cracks on a surface, is not able to be detected just through thermographic inspection. So what I propose is we may be able to couple the thermographic inspection with say ultrasonic testing, so that it will go hand in hand and you'll be able to get the desired output that you want.
Thank you.
Yeah, Niroshan, if I add one thing to more, that is basically helicopters, rotor blades. That is especially this thermographic inspection, they are planned to design for the honeycomb structures. So especially water intrusion, to check that one. So that is the good idea for that one. Okay, sir, thank you very much then. That was a very nice presentation and that good Q&A session. You can see.
Thank you very much.
Thank you.
So our second topic today is going to be, that is also another very interesting aerodynamics topic, estimation of lift hysteresis of an airfoil in a low speed flow. So there are two, author is Mr. W.R.D. Jayakody. He is an undergraduate at the Department of Aeronautical Engineering at the Faculty of Engineering of Sir John Kottala, Defence University. So regarding this topic, I think that is also very interesting one, and especially regarding the today's context, the unmanned aerial vehicle. The study of the properties of moving air and interaction between the air and solid bodies moving through its defined as the aerodynamics. It is one of the principal subjects that undergraduates of aeronautical engineering are supposed to undergo. Lift hysteresis of an airfoil is a phenomenon leads to difference, separation, and reattachment angle of aerofoil at an angle of attack near and above stall. This occurs when there is a difference in the lift distribution of an airfoil than expected for a given angle of attack when recovering from a stall. This leads to asymmetric flow parameters around body even when boundaries remain symmetric. These advanced aerodynamics phenomena, such as lift hysteresis of an airfoil, are necessarily required to be understood by the aeronautical engineers in order to design airframe structures or to estimate performance parameters of existing airframes. The interest on low-speed flows has been increased lately due to the increased application of unmanned aerial vehicles. The very phenomenon we discussed today, the hysteresis, is difficult to predict due to its inherent physics and extreme sensitivity to the environmental condition. In terms of acoustics, structural, pre-stream turbulence distributions. The research we present today will be based on the research undertaken by Mr. Jayakody and supervised by J.I. Abhiyagunawardena to enhance to a spectrum of knowledge in this area to study. With that, I would welcome Mr. Author to present your presentation.
Thank you for the introduction, sir. Good morning, distinguished chairperson, senior officers, academic staff, ladies and gentlemen. Our research topic is estimation of lift hysteresis of an airfoil in low speed flow. So the outline of our presentation is as shown on the screen. So first, let me give you a brief introduction about what aerodynamic hysteresis is. So sometimes, even though the boundaries might remain symmetric, still when there is large regions of flow separation, this would result in instantaneous and mean flows to be different. So this could lead to hysteresis. Now hysteresis is the forces and the moments which are acting on a body could actually depend on the time history of the attitude. Now as shown in these figures, at a particular angle of attack, 14 degrees, the oil flow visualization shows that initially the right wing has a flow separation, and then the left wing has a flow separation. So this has fluctuated, the forces has fluctuated. So moving on, our area of study is static stall hysteresis. So this static stall hysteresis means it refers to the dependency of the current state of the flow on the flow's history of attachment. So to simply put into words, it means for a particular angle of attack, for a particular airfoil, there exists more than one coefficient of lift, drag or moment. As you can see in the figure, the coefficient of as you can see in the figure here, the reattachment point as well as the stalling point has changed because of this hysteresis effect. And also within this hysteresis loop, there's different coefficient of lift values for the same angle of attack. So there are different hysteresis loops. It could either be clockwise hysteresis loop or anti-clockwise hysteresis loop. For the Reynolds number of 150,000, for the Miley, it's an anti-clockwise hysteresis loop, and for the Lissaman airfoil, it's a clockwise hysteresis loop. So there are various factors affecting the extent of the hysteresis. It could be Reynolds number, turbulence intensity, camber, model imperfections, the flap angle. All of these properties affect to what extent the hysteresis is being made. So why do we study hysteresis? So as I mentioned earlier, there's a difference between the stall and the reattachment point. So assume that the aircraft is flying in the air and the aircraft is stalling when we increase the angle of attack. But now, since the aircraft is stalled, just because we decrease the angle of attack up to the stalling angle that it initially stalled, we cannot have a attached flow. We'll have to further decrease the angle of attack in order to have a reattached flow. Now, so as you can see, these stall conditions and spring flight conditions are being affected by this hysteresis effect. Also, for a given angle of attack and an airfoil, as I mentioned before, the lift coefficient and the lift to drag ratio is different. if we consider the wind turbine blades, because of this hysteresis effect, the blade fatigue is increased, and hence a short operational life will be available. So talking about the existing literature for an experiment conducted on the Lissaman and the Miley airfoil, it was shown that the increase in the turbulence caused the hysteresis loop to reduce or actually disappear as well if we further increase the turbulence. Also, in one of the tests conducted on a NACA 0018 airfoil, the stall hysteresis loop increased with the Reynolds number, and another test conducted on a NACA 0012 airfoil showed that there was a significant relationship between the difference between the reattachment point and the stalling point on its effective body. So our research is also a continuation of this last point that I mentioned. So moving on to the research objective, what we wanted was to analyze the relationship between the Reynolds number and the static stall hysteresis of an asymmetric airfoil empirically. So as you can see, an airfoil has a physical body as well as an effective body. So actually what the flow sees is not the physical body, but instead it's the effective body. So as you can see here, the smoke wire visualization for a NACA airfoil, we can see that the flow has actually followed a path which is different to its physical body. Also, for lower angles of attack, this is of course not much of a problem because the physical body and the effective body is more or less the same. But for high angles of attack, when the angle of attack increases, there will be a large wake created, and hence the effective body and the physical body is somewhat different. So as you can see, this is the physical body and the effective body of a NACA 0012 airfoil. There's a drastic difference between these two. So moving on to the methodology. The methodology of our research is as shown on the screen. So we selected an airfoil, the Clark Y14 airfoil. We did the experiments using the Aerolab education of wind tunnel with characteristics mentioned on the screen. We selected the Reynolds number range by considering the characteristics of the wind tunnel, and we got a Reynolds number range of 27,423 to 396,122, and the experiments were conducted for the Reynolds numbers shown on the screen. This is the experimental setup. We mounted the airfoil vertically and we connected it to the liquid manometer, and the pressure variation of the airfoil was measured. The coefficient of pressure was calculated by using this equation, and MATLAB was used in order to calculate the lift curve, and the area between the coefficient of pressure of the lower surface and the upper surface was used in order to find the coefficient of lift. So moving on to the results and discussion, as you can see, this is the CP variation for different Reynolds for the Reynolds number of 112,742 is given. Here at 5 degrees, the flow is completely attached. So even though the angle of attack was increasing or decreasing, we have more or less the same variation for the CP. But at 10 degrees, when the within the hysteresis loop, for the increase in angle of attack and for the decrease in angle of attack, the CP variation is somewhat changed, is entirely different from one another. Also at 15 degrees, when the flow is completely separated, the increase in angle of attack and the decrease in angle of attack gives the same, more or less the same results again. So these are the variations, CP variations for the other Reynolds numbers. So moving on to the coefficient of lift variation, as you can see, the hysteresis is being seen here very clearly, and we can see there's a difference in the stall and the reattachment point, and with the increase of the Reynolds number, this hysteresis loop has increased, and again the hysteresis loop has decreased a bit when we increase the Reynolds number further. So moving on to the findings, as I mentioned earlier, so at lower Reynolds numbers, at 79,224 Reynolds number and below, we actually did not find any hysteresis loop at these Reynolds numbers. But when we increased the Reynolds numbers, we found there was a really good demonstration of the hysteresis loop. The hysteresis loop was very well visible, and then it increased with the Reynolds number, and at 134,072 Reynolds number, we had the highest hysteresis loop at an angle of 7 degrees. And further, when we increase this Reynolds number, the extent of the hysteresis decreased to 5 degrees. And also the stalling angle, variation of the stalling angle with the Reynolds number, continuously the stalling angle increased with the Reynolds number. So moving on to the limitations of our research, this test was done for a 2D airfoil. Also we had the ability to only vary the angle of attack by multiples of 1 degree. We did this experiment for the incompressible region. The pressure readings were based on the liquid manometer. So whatever the errors associated with the liquid manometer are included in this results, because the time interval also we need to let the pressure readings to settle down before we take any readings in the liquid manometer. Also the human errors while measuring this is also available. So moving on to future work, we expect to carry more internal experiments in order to increase the accuracy of these results, and we will be conducting CFD simulations to validate these experimental results, and we'll model the effective body of the stalled airfoil, and once we model it, we'll run the CFD simulations for this effective body and determine the relationship between this effective body and the hysteresis loop of the airfoil. So moving on to the conclusion, we studied the effect of Reynolds number on the hysteresis loop, and we found that there were no considerable hysteresis loop observed for low Reynolds numbers, but when the Reynolds number was increased, there was the hysteresis loop was present, and it continued to increase and then again decrease with the Reynolds number. So the extent of the hysteresis loop was actually seen to be dependent on the Reynolds number. So I would, moving on to the acknowledgement, I would like to specially thank the academic and non-academic staff of the Department of Aeronautical Engineering of Faculty of Engineering at General Sir John Kothalaval Defence University. The references that I used are as shown on the screen. Thank you.
Okay. Yeah. Once again, thank you very much, Mr. Jayatilaka. You are on time. And then more theories regarding the aerodynamics. If you have any questions or further clarification, you can ask now.
Okay, thank you very much for your nice presentation. And as per your results, it is observed that there's no hysteresis loop at low Reynolds number.
Yes.
Does it due to the resolution of the water manometers in the wind tunnel? Because you have mentioned one of the limitations that you have faced is the water manometers. So have you looked at in that aspect as well, since you did not observe any loop at the low Reynolds number? Any comments on that?
Thank you for the question, sir. Actually, that also is one of the factors that for not having good results for the low Reynolds numbers, because the readings of the pressure liquid manometer was real difficult to read, as I mentioned, because we had to visually read it. But actually at low Reynolds numbers, still there was no any hysteresis loop to be obtained. And I cross-checked with some references as well, and from those references as well, it was mentioned that for very low Reynolds numbers, and also this depends on the airfoil, the shape of the airfoil as well, hysteresis could not be observed for some airfoils, and also the reason that Sir said was might also be included because there's difficulty in measuring the pressure values as well, but mostly there was no hysteresis to be obtained, sir.
Right, again, thank you very much for the very interesting research. Now, what I understood was you had developed a correlation between the angle of attack and the Reynolds number. in terms of the phenomenon of hysteresis. Now, have you looked at the other factors like the Mach number, the turbulent intensity?
Yes.
Because when there is turbulent intensity, high turbulent intensity, then there is every possibility to have reverse flow. So have you looked at that aspect also?
So now in the wind tunnel at KDU, sir, here there's the turbulence intensity cannot be changed. That's one. And also, sir, the Mach number is not that much of a point to be considered because we are considering the low incompressible regions. And also, as I mentioned in one of the slides, the turbulent intensity actually has an effect on the Reynolds number. When we increase the turbulence intensity, the Reynolds extent of the hysteresis loop actually decreases. But the problem is we do not have the ability to vary the turbulence intensity at our wind tunnel, but we could still increase the surface roughness by maybe attaching some threads or things like that, and maybe we can increase the surface roughness, because the surface roughness is also said to have the same effect similar to that of turbulence intensity. So if we were to increase the turbulence intensity, we could get we could see the change in the hysteresis loops.
What is the critical Reynolds number that you would like to look at in terms of hysteresis? Is there any critical Reynolds number?
So we cannot say that there's a critical Reynolds number for the entire hysteresis to be seen and not seen, sir. It depends on the airfoil and other conditions as well, sir. For this particular airfoil, sir, we could not observe any hysteresis below 79,000 Reynolds number, but this might be different for another airfoil, because entirely it also depends on the shape, because this depends on the effective body. When the airfoil is tall, there will be an effective body. So when we are decreasing the angle of attack, this effective body will still be intact, and whatever the readings that we are going to get, this effective body will have an influence in them. So this depends on the shape and the other factors as well, sir.
Thank you.
Okay.
With the temperature, so these turbulence densities might be changed, and the streamline phenomena also might be changed, and the lifting and dragging force also will be changed. In which temperature did you?
Sir, we did this experiment at standard sea level conditions at 28 degrees Celsius, sir.
28.
But yes, sir. But if we were to do this at different temperatures, yes, the results would be different, because even the pressure readings of the manometer would change, sir. Yeah. And also the turbulence intensity, and those will be affected, sir.
Yeah. Thank you.
Okay, thank you very much. That was a very interesting, more theory involving presentation, and we can see that you are very conversant with the theories. Thank you very much, Mr. Jayatilaka.
Thank you, sir.
Next presentation regarding communications, not the aviation communication, an analysis of impact, technical communication on aviation risk mitigation in the context of aircraft maintenance operation in Sri Lankan context. So, authors, there are two authors. Mr. KMGMWB Samaragong is a graduate of Department of Aeronautical Engineering at the Faculty of Engineering, General Sir John Kotalawa Defence University. Other one, Mr. SCM Bandar is a graduate of Department of Aeronautical Engineering, Faculty of Engineering of General Sir John Kotalawa Defence University. So this is also another interesting topic, and I think they have done research, not aviation communication, regarding technical communication. So if I add something, it is safe for me to declare that the air travel today is the safest mode of transportation available to public. Although aircraft remains to be fragile piece of equipment, the safety and quality control inputs into the air travel industry in general has made this possible. A key component for keeping the air transportation a safe way to travel is a safety management system, or SMS, undertaken by airline and various stakeholders in this industry. The next paper we are going to discuss today explore the impact of technical communication on aviation risk mitigation in the context of aircraft maintenance operation in Sri Lanka. Technical communication directly affects aviation safety through written and verbal communications, lapses, misunderstanding, language problems, pronunciation, misinterpretation, etc. The situation is more complicated when considering the dynamic environment of flight line maintenance and base maintenance activities, where the fluctuating maintenance demand is to be fulfilled with the limited resources without compensating the quality and standard of the aircraft industry demands. The presenters of this research have undertaken a much needed area of study in Sri Lankan aviation industry, as there are only finite number of empirical research available locally on this subject. After all, we cannot simply apply research done by elsewhere directly to our context, as our ways of communication and understanding of instructions differ from the rest of the world. The research has undertaken by the undergraduates of this university with their instructors, namely Mr. Bandara and Mr. Samarakon, with the supervision of Dr. Tusita Rodrigo. So, gentlemen, now over to you. You can start your presentation.
Good morning, ladies and gentlemen. Today we are going to present an analysis of the impact of technical communication on aviation safety in the context of aircraft maintenance operation in Sri Lanka. This is our content. First, our background. In Sri Lankan aviation industry, we can find only few researchers in under safety management system. Because we are going to do this, what of the reason of that, and we hope to develop the safety management system researchers in Sri Lankan aviation industry. Also, we connect safety management system through the safety promotion. By enhancing safety promotion in Sri Lankan aviation maintenance organizations, we can minimize the rate of accident and incidents. And we want to highlight the direct effects of communication to safety promotion. This is our introduction. This is the ICAO SMS module, Annex 19. These four pillars mainly foundation of the SMS. Then we connect with the safety promotion, because safety promotion is the most suitable way for doing the researches. And we connect through the SMS safety promotion. Safety promotion connect with the technical communication. Written verbal communication, information understanding, and employee engagement and feedback are the sub-independent variables through the communication. These are our objectives. develop and highlight the safety management system directives in Sri Lankan aviation industry. Then, to identify the main factors that affect to the safety promotion toward risk mitigation. And also develop a conceptual framework to know how communication affects the safety promotion toward risk mitigation. This is our methodology. Safety management system, safety promotion, technical communication. These are the main variables, but we have to show how to connect between those things. Then we develop a conceptual framework with sub-independent variables. Written verbal communication, information understanding, and employee engagement and feedback are the sub-independent variables. Then we design the questionnaire-based conceptual framework with Likert scale and collect the data by online. We gather data generally for main organizations with one government organization and 3 private aviation organizations. Then we statically analyze by IBM SPSS software. This is our conceptual framework. The safety promotion connect with communication. The communication is under safety promotion variable. This is the independent variable. Main independent variable is a communication. Then written verbal communication, information understanding, employee engagement are the sub-independent variable. This is the dependent variable, risk mitigation. I hand over to Chatura to the rest of presentation.
Thank you, Mahen. These are the 3 hypotheses that we developed to conduct our research. And according to these hypotheses, we considered our null hypothesis. These are our results. By analyzing our data, first we get the correlation test. So we use the Pearson correlation to know that there's an adequate relationship between the dependent variable and the independent variables. So we get the values that proper correlate relation range should be -1 to +1. So all the Pearson correlation values are in that acceptable range. And so we can conclude that all the value has the positive strong relationships. And according to that, all hypotheses we can accept because the significant value is less than 0.05. This is the coefficient table we go through the regression analysis. So according to the regression equation, this regression equation we develop. According to that regression equation, if we change one unit in our independent variable, it mentioned that how much of effective on the risk mitigation when keeping other independent variable stays constant. These are the recommendation we got through our research. So through the research finding, safety promotion is main factor to upgrade the safety in Sri Lankan aviation industry. So safety promotion is the most important channel to go through this safety management system. So since most possible way for risk mitigation is to improve safety promotion through sub-variables, by using employee feedback system management can ensure that subordinates could properly understand the communicated information. And also for safe communication, language proficiency of the employee is also very important. And discussion. So we mainly focus in this research to analyze the relationship between safety promotion and risk mitigation through the communication. According to our findings, we got that the strong positive correlation between independent variable and the dependent variable. And also for technical understanding about the maintenance information and production planning, information and information understanding and the language proficiency also very important. Conclusion. So we conclude that the written verbal communication, information understanding and employee engagement and feedback have positive impact on risk mitigation towards safety promotion. So using employee feedback system can ensure that subordinates properly understand the communicated information. And according to finding, employee engagement and feedback have highly affected for the risk mitigation towards safety promotion. And also management has to concern about the employee OSH awareness and corrective actions. How did they aware about these corrective and preventive actions, and take effective actions to develop, improve the written verbal communication, information understanding and employee engagement and feedback. As limitation, we consider only the line and base maintenance only, and we can develop into the cargo handling departments and ground operation crews. Acknowledgement. We would like to express our deepest appreciation to our supervisor, Dr. W.T.S. Rodrigo, who motivate, advise and encourage us regarding our research. And we would like to extend our sincere gratitude to the Department of Aeronautical Engineering, all academic and non-academic personnel who have helped us all along. Thank you.
Okay, thank you very much, Mr. Samarakon and Mr. Bandara. You took almost 8 minutes to cover your presentation. So communication is a very important topic in the aviation industry, both aviation communication and the ground communication. They talked about ground communication. So if you have any questions regarding ground communication, you can ask now.
Explain me the issues that you have identified in verbal communication.
Thank you very much for the question, sir. In the verbal communication, with the background, when we have engaged with the line maintenance, with the background noises, some employees don't use the verbal equipment communication. To communicate, they don't use the equipment to communicate in their maintenance practices. That's the main issue we have identified.
In terms of then the communication related to the documents, what are the issues that you have identified?
When the shift handovering in some private maintenance organization, they don't follow the proper practices. According to that, they don't use proper documentation and they only use the verbal communication to shift handover, and that will affect to some incident or accidents.
Thank you.
Any questions from the backside? I think no more questions, but that is a very useful topics today's context. Even the communication, due to lack of communication, there are catastrophic failures in the aviation industry. Even they lost aircraft and even passengers, human beings. So that is, thank you very much. Again, Mr. Samarakon and Mr. Bandara have done good presentation. Thank you.
Thank you very much.
Today's last topic, going to do this topic is an empirical analysis of the impact of aircraft maintenance technical training on risk mitigation in the Sri Lankan aviation industry. So same kind of topic earlier, the risk of technical communication, now technical training. So the two authors, again, Mr. S.C.M. Bandar is a graduate of Department of Aeronautical Engineering at the Faculty of Engineering of General Sir John Kothala Defence University. Another one, KMGMWB Samarakom, is a graduate of Department of Aeronautical Engineering at the Faculty of Engineering of General Sir John Kothala Defence. Same authors. I will give small introduction about the technical training. This is our last research paper for the day. We have another research undertaken by the same team, I think, same team of the previous paper. We discussed, and their subject is also somewhat similar to the subject we discussed previously. This is an empirical research on the impact on aircraft maintenance training in Sri Lanka on risk mitigation. This is once again, is timely project undertaken by the team of researchers, as there are a lack of empirical research done in Sri Lankan aviation industry. I don't have to emphasize on the importance of safety management system on an airline or related institution towards the safe operation of aircraft. The operational efficiency of aircraft maintenance activities is pivoted on the equilibrium between safety and productivity. Against this backdrop, aviation safety management system play a vital role in ensuring safe operation while enhancing operational efficiency. Aircraft maintenance in-flight activities, maintenance manual, repairing data records, correct procedure, etc., are affected by effective technical training and education. Without proper training and education, aircraft safety will entirely collapse. All modern commercial aircraft associated equipment are highly complicated, and any person who performs maintenance activities on them needs to have a high depth exposure and training, without which it will endanger both safety of the aircraft and passengers who are flying on board. This research discusses each part of this training, and on findings of their empirical research, they will present what parts are more valuable and what emphasis needs to be put on each part of the training. So therefore, once again, I would like to invite Mr. Bandaran, Mr. Samarakon, to enlighten us regarding the aviation training, technical training. Thank you.
Thank you. Good morning, ladies and gentlemen. Today we are going to present about an empirical analysis of impact of aircraft maintenance technical training and education on risk mitigation in the Sri Lankan aviation industry. This is the content we are going to follow through our presentation. Introduction. In a safety management system, we can consider it as a systematic approach to the managed safety. That means that in aviation industry, safety plays a vital role, and also the aviation industry cannot be completely free of hazards and the associated risks. So the purpose of this research is to evaluate the effectiveness on the risk mitigation in the aviation related organization when we change the training and education variables. As the training and education variables, we identified that initial training, continuous training, and training resources availability are the most effective factors for risk mitigation. In our research, we have considered the safety management system. According to that, safety management system have main four pillars. In safety promotion is the one main four pillar for the going through the risk mitigation. Research questions. These are the research questions we found that we are going through the research. Here we consider the impact of training and education towards risk mitigation and affecting factors for the risk mitigation. Objectives. These are the objectives we found. Objectives we have to carry out in our research. Here, according to our literature review, that there are lack of research conduct on safety promotion and risk mitigation in Sri Lankan aviation industry. So we have to identify the factors affect on risk mitigation towards training and education and evaluate the impact on it. Methodology. So we have done this research as a hypothetic deductive approach based on an empirical review and also research conduct on a quantitative method. And by developing conceptual framework, we can link the risk mitigation and training education with sub-independent variables as initial training, continuous training, and training resource availability. So we have distributed our questionnaire among 200 of employees, and we got 150 feedback to carry out our research. And we analyzed our research by using SPSS. In analysis, we consider the normality, multivariate, correlation, and regression. This is the conceptual framework we have developed under safety promotion. Our main variable is training and education. According to that, we link risk mitigation through the initial training, continuous training, training resources availability. I would like to invite Mahen to continue the presentation.
Thank you, Chatura. This is our hypothesis. These hypotheses depend on the initial training, continuous training, training resource availability. Results. First, correlation. The Pearson correlation is for test relationship between independent and dependent variables. This range should be -1 to +1 in all our results within the range, and also we can accept the all results. Here, regression. Regression is a numerical tool to study relationship between variables. According to the model, R value indicate positive linear relationship between overall in these variables. This is our regression equation we developed. According to the beta values, we derived this coefficient table. Then this indicate changing one unit of independent variable, how much to affect on risk mitigation, keeping other variables constant. Discussion. Mainly focus in this research to analyze the relationship between these channels. In aircraft engineering aspects, have to concern especially on initial training for every technician and engineers, and continuous the safety assurance and recurrent training also important. Most of organizations have lack of budget allocation for training resource, but according to our findings, it is essential thing. Conclusion. Language proficiency of employee develop innovative training system. Also, informally conduct safety audit, also essential for safety. And continuous training is very important to every employees and directly affect to the safety. Further research can be carried out, considered qualitative data gathered through interviews and focus group discussions. Acknowledgement. We would like to express our deepest appreciation to our supervisor, Dr. W.T.S. Rodrigo, who motivate, advise and encourage us regarding to our research. And also we would like to extend our sincere gratitude to Department of Aeronautical Engineering and all the academic and non-academic personnel who have helped us along. Thank you.
Okay. Once again, thank you, Mr. Bandara and Samarakon. Regarding training, they were discussed about 3 main training: the initial training and the continuation training and the training resources available for the training. So if you have any questions regarding any thing relevant to the subject, you can ask now.
Sir, actually this is not a question that I'm going to ask, but as a supervisor, once they were conducting the 2 presentations, I understood that there are certain areas that which needs further clarification. So first I would like to congratulate them on their 2 researches, because this was based on their final year project. Because in aircraft maintenance engineering, we cover a subject which is called aviation safety management systems, which is very important, because which talks about the equilibrium between safety and productivity in aviation. Because wherever you increase safety, the productivity is compensated. Wherever you increase productivity, the safety is compensated. So in order to manage that, we have the concept of safety management system. So in the normal context of safety management system, most of the topics are already covered. If you look at safety risk management and safety assurance, it has been researched continuously. So therefore, I basically inspired students to research more on the promotion aspect, which is being divided into 2 areas, that is the training and the communication aspect. Because we see as the practicing engineers, there is 2 areas where we are lagging a lot. So their first paper was mainly focused towards the training, the communication aspect. So there we have, through an empirical analysis, we were able to identify there are significant problems available in the industry. So we need to take action. For example, like the effective communication is not there and we need to promote them, especially in the military context. And then we moved on to the technical aspect, technical training, where because of the cost involved, sometimes the organizations tend to pay less concern on the training aspect, which has adverse and a sort of snowballing effect on the end result of the safety. So I think those are the main 2 findings that we were able to find. And the reason why they went for 2 papers is that if you have to combine training and communication, that would give an odd shape for research. So that's why they were mainly looking at the 2 components separately. So I thought, as the supervisor, it's my duty to enlighten the audience. Otherwise there might be concerns like why 2 papers are being presented by the same 2 authors. So I congratulate you and thank you very much.
Thank you very much, sir.
Thank you. Any clarifications or any questions? If you don't have any questions, I think now time to sum up this session. Today we discussed almost 4 topics related to the aircraft maintenance industry. Maintenance. First one, thermographic inspection, system for surface scouting, defects on aircraft fuselage. That is innovative subjects and innovative topic you are going to do, and I hope that you will continue and we can see the results in future. So that is new thing. If you can innovate that product, that is very helpful. We know that how cost will involve for the NDT inspection in Sri Lanka, even Air Force. So that is a very effective topic, and thank you very much. So I hope that will continue. Second one, that is basically aerodynamics, more theoretical part, estimation of lift hysteresis of airfoil in a low speed airflow. That is again the relevant topics regarding the much of them can't do in outside this kind of topics, because you have the wind tunnel and other facilities you can do in KDU. So that's why that is also very good thing related to the UAVs. That is very common topic in Sri Lanka in aviation industry. Third topic is, as clearly mentioned Dr. Dushantha, that it very rare to researchers have done in Sri Lankan aviation industry regarding technical communications and training. So those two topics are very rare and very important, but much of the aviation even engineers or technicians, they are not giving due recognition to that two topics. But when you got some issues or problem, then they are highlighting the importance of these two topics. So that is also another good two researches done by the Mr. Bandara and Mr. Samarako. So thank you very much. Once again, if you have any questions regarding any subject, you have 1 minute, or otherwise we can conclude this session. If you want to tell anything regarding your topics? No? So then once again, thank you very much. All the evaluators, senior professors, senior lecturers, head of the Department of Aeronautical Engineering. And once again, I would like to thank Vice Chancellor and the Dean Faculty of Engineering and the head of the Department of Aeronautical Engineering, all the staff members and academic staff who invited me to chair this session. Thank you very much, and I wish you all the very best for the authors and all the undergraduates who are studying in KDU. Thank you very much.
Thank you, sir. Ladies and gentlemen, now we have come to the end of the technical session, which was really interesting. Now, I would like to invite Air Vice Marshal LMSK Leela-Ratne, retired, accompanied by Dean, Faculty of Engineering, Captain S.U. Dampage, retired, to award certificates to the authors who presented in the session.